Alright, so this video for month 1560, Calculus 1 at U of L for fall 2017 is something that you might find useful when you're working on assignment number 5, which asks you to do some of these calculations, asks you to do midpoint and trapezoid calculations. I should probably emphasize that this question on the assignment will be the only point in the course where I'm going to ask you to use midpoint or trapezoid rules, so you don't have to worry too much about this, but if you want to get through that assignment, you might find that this video comes in handy. Alright, so one of the things that we've seen in some of the examples is if you're dealing with an increasing function, if you're dealing something where the graph is going up, and you want to calculate the area under this graph, and you choose your partition and you decide to use right endpoints for each of your subintervals, well then you always get an overestimate. Okay, you get an overestimate for each one of your rectangles. Right? Each rectangle is above the graph. On the other hand, if I were to use left endpoints, well then I get this underestimate, right? And the estimate that I get is too small. The true area lies somewhere in between the underestimate and the overestimate. And so there are two techniques that you can use to mitigate this problem, that using either left or right endpoints gives, is kind of giving you the worst possible estimate. One of the ways to improve the estimate is to say, well, the problem is being caused by the fact that our function is increasing, and going on the far left or the far right of each interval is kind of the worst case scenario, so why don't we go right in the middle, right? So that's the midpoint rule. The midpoint rule says just choose the center of each interval. So if you take the two endpoints and you average them, you land right in between, right? So this is a case where your interval xi minus 1 is here, xi is there, and you choose ci right in the middle. Okay, so in the midpoint you're kind of you are averaging the inputs, right? You're averaging the x values. In the trapezoid rule, what you're doing is, instead of averaging those inputs, you average the output, right? So you take the upper sum, which is the biggest overestimate, you take the lower sum, which is kind of the lowest underestimate, and you take the average of those two, and you hope that the area should be somewhere in between. So we're going to try these two techniques in a fairly simple example, and we're going to see how they perform. Okay, so we're going to do y equals x squared from 0 to 2, and let me tell you that the true area here, the true area, we sort of saw this on the last video, the true area is given by 8 over 3. Okay, so we're doing 4 subintervals, so our delta x here is 2 over 4, it's 1/2 or 0.5, right? So x0 is 0, x1 is 0.5, x2 is 1, x3 is 1.5, and x4 is 2. Those are our points. And so what are our midpoints? Our midpoints are halfway in between each of these. So our C1 is halfway between 0 and 0.5, so it's 0.25, or in other words, a quarter. C2 is halfway between 0.5 and 1, it's 0.75, right, or in other words, 3/4. C3, again we see that's 1.25 or 5/4, and C4 1.75, which is 7 over 4. So those are our midpoints, and so our area approximation here, our area is approximately, so what's it going to be? It's f at C1 plus f at C2 plus f at C3 and f at C4 times delta x. Okay, there's our Riemann sum. So what does this come out to be? This comes out to be 1/4 squared, 1 over 16, 3/4 squared, 9 over 16, 5/4 squared, 25 over 16, and 7/4 squared, so 49 over 16 times 1/2. And so that is going to come out to be, so 49 plus 150, 75 plus 9 more, 84, and 16 times 2, 84 over 32. Let's just work that out. 84 divided by 32, so 2.625. Okay, we can do that. Come on, there we go. So this is 2.625. And this true area, I guess we want to compare, we should actually get a decimal there, right? So what's the true area? 8 divided by 3, 2 points, well, and a whole bunch of 6s. Okay. So to 2 decimal places, or let's say 3 decimal places, 2.667. Alright, so that's not too bad. At least we've got it to 1 decimal place. So, you know, depending on how accurate we want to be, we can live with that. What about the trapezoid rule? So, and by the way, why is it called the trapezoid rule? Let me draw you the picture. So here's our graph. Here's our, and so we've got our rectangles. So what we're really doing here is, and let me kind of maybe make this a little bit bigger so we can see it. What we're doing is this. Here's our graph. Here what we're doing is we're calculating actually this, so we're doing this thing here, right? So when you have a trapezoid, your trapezoid looks something like this. Okay, so there's kind of a base, there's a yeah, maybe we'll say W for width, and then there's 2 sides, A and B. And the area for something like this is, it is 1/2 A plus B. It's the average of the 2 times the width, right? And so that's what we're calculating here when we're doing the trapezoid rule, right? Because we're doing, you know, for each of our AIs, we are doing f of xi minus 1, f of xi over 2 times delta x, right? And so this really is, this is kind of your 1/2 A plus B, and the delta x is really your W. And you can see that, you know, now those are straight lines, so they don't, and part of the problem here is that, you know, it's hard to draw things so that it doesn't look approximately straight. So those lines should be straight, and we can see that you know, these trapezoids, you know, they should track the area pretty well. So again, we have our delta x is 0.5, and so for the lower sum, we use f of x naught plus f of x1 plus f of x2 plus f of x3 times delta x. So, and remember that x naught is 0, x1 is 0.5, x2 is 1, x3 is 1.5, x4 is 2. So, and our function is a squaring function, so this is 0 squared, which is 0, x1 squared is 0.25, 1 squared is 1, 1.5 squared is 2.25, okay, times 0.5. So this gives me 3.5 times 0.5. Okay, so that's, so 3.57 over, this is 7 over 4. The upper sum, well, we start at 1. And now we go up to x4. Right? So we leave off that left endpoint, that's 0, and we start at at x1. So we get the 0.25, we get the 1, we get the 2.25, and then we get x4 squared, 2 squared, we get 4 times 0.5. So now we've got 4, 6, 7, 7.5 times 0.5, right? So that's 15 over 2, 15 over 4. And so the trapezoid is we do 1/2 of the lower sum plus the upper sum. So we do 1/2 of 7 quarters plus 15 quarters. That's 1/2 of 22 over 4, which is 11 over 4. Okay. And again, we check and hope that I didn't make any calculation errors there. 11 over 4, and we get 2.75. Okay. 2.75. I guess I could have done that one without the calculator. Okay, so 2.75, and again the true area was the true area was 2.667. So again, we're off a little bit. This time we don't quite get the that first decimal place because we've got an overestimate rather than an underestimate, but we can see that we're in a pretty good ballpark here, right? This time we overestimate slightly, but we've got a pretty good idea of what the area should be. Okay, so those are the midpoint and trapezoid rules. You'll find that those come in handy when you're working on your last written assignment.